All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue working on the Stream AI voice app. Actually, no, is that what we are working on? No, the auto clipper app. We're going to continue working on the auto clipper app. We are currently working on the first stage, which is actually wasn't the first stage pre-processing. Maybe I shouldn't be trying to number the stages. Give me a second here. I just need to CD snuts, but I need to CD back into this, and then we have the mind map there. So I need to HMM project mind map.hmm. So this is our mind map, and yesterday we determined that, okay, so our first step is pre-processing, right? I actually need to do that. I need to, you know what, we could do that right now. So I'm going to open up a new Gemini instance. I'm going to open up a Gemini web instance. And I'm going to say, okay, I have a 2.5, or let's say 2 hour long Twitch VOD in MP4 format. I want to use FFmpeg to split the video and audio. Is that possible? I know that the audio can become some sort of audio format like wave after the split, but what about the video? What about the video part of the file? Actually, what I wanted to ask was if Gemini could help me with the actual commands, but then I got this question, so I decided to ask the question. Now, real quick, something that I'm gonna do here is grab the okay, let me open up Yahtzee and open a new tab, and then go into, I believe it's in downloads. Let's sort by the modified date. Just a second. Oh, wait, what's going on here? Run preloader, fetch video. Oh shit. Okay, don't do that. Let's not do that. Let's just go back. Okay, cool. Now let's go into downloads. And yeah, there we go. So I got a VOD just yesterday. Actually, I don't remember how many I downloaded. Wait, today is, yeah, okay. I think I actually downloaded all of them. Yeah, you know what we're gonna do? We're gonna use the latest VOD. So I'm gonna yank this and come here, and let's create a folder called yeah, let's just create a folder called data and paste it here. Now, once this copying is done, then I can go back to the other tab and close it. Just give it a couple of seconds, because this is actually a pretty long VOD that I'm looking at. I think this was maybe 2.5 hours. It was definitely two hours, between 2 and 2.5 hours. So maybe 2 hours and 15 minutes probably. I'm gonna have to check the details on the thing to find out. Okay, the copying is done. This is basically yesterday's VOD. Let's look at the details. It says duration 152 minutes. So if 120 minutes is 2 hours, then plus 30 minutes would be 2.5 hours. I'm assuming that duration is in minutes. So yeah, 2.5 hours. Great. So this is a perfect example, actually. Maybe I could rename this. Yeah, I don't think the date matters anymore here. So I can rename this to test underscore vod 01 underscore 01. By the way, quick thing. There was a project that I was planning on doing a while back. So like the mice that I have, because I have multiple mice, not just one, for multiple computers. I mean, so the mice that I have, usually their mouse wheel goes bad fairly quickly. One of the reasons is because I'm usually using cheap mice, and I'm actually really surprised with how long the wheel has worked on this specific mouse keyboard set that I'm using. It's this keyboard that has like these sounding keys, keys that sound like this. Basically, this is one of the best keyboards that I've had up until this point. This is one of those keyboards that made me realize that I actually like keys that are spread out much more, or rather, I should say, keys that are not in a compact form, because being able to spread out my fingers, it really helps my efficiency a lot more than, if I was trying to squeeze my fingers in with like a smaller, what do you even call it, smaller form factor of a keyboard. I realized that I like these kinds of keys much better, and I also like the bit of dip that they have when you have to press the key. I like this kind of a keyboard. The specific keyboard that I have is, I'm trying to read the thing. The box is upside. Oh wait, there's another. Okay, KM500 Pro, I think. Let me just look that up, and then I can tell you guys. Give me a second. KM500 Pro. Yeah, it's Ant Sports KM500 Pro. So my mom had she had taken a trip to India recently, and during her trip, my uncle was asking if I wanted one of these keyboards, and so they asked me, and I took a look at the thing. I had no idea what I was getting, but I just knew that I wanted a wireless keyboard and mouse. Like whatever I was gonna get, it had to be wireless keyboard and mouse, both. Because I mean, you don't need to have separate receivers for like the keyboard and mouse. At least for my purpose, having one receiver for both the keyboard and mouse, it works great. So like that was my main requirement, that it has to be a wireless keyboard and mouse. And a massive bonus that I got, aside from getting this amazing keyboard that feels just incredibly amazing to type on, an added advantage that I got is the fact that this is an RGB keyboard. So this made me realize that I actually need RGB keyboards, because I do a certain amount of my research and coding and stuff in the dark where I don't have light. So that was one thing. One major advantage that I got was that it's RGB, and another huge advantage is that both the keyboard and the mouse, they have their own rechargeable batteries. So you don't have to keep replacing the battery. You just have to charge the keyboard and charge the mouse whenever the charge runs out. And I really like that idea. I like that idea a lot. That actually made me consider doing some research on the whole idea behind rechargeable batteries and how I can apply rechargeable batteries to my current setup, which uses the regular, like, AA and AAA batteries, which I have to keep buying every now and then. So Yeah, I forgot why I was talking about this, but yeah, why was I talking about the keyboard? I forgot. Anyways, test underscore vod underscore one underscore o one. And I guess we are good. So I can close this now and open up the mind map again. Great. So, what we need to do, oh, yes, I was having this. Oh, yeah. The reason I was talking about the keyboard and the mouse is because I was talking about how my mouse wheels they go bad pretty quick, at least on the cheaper mice. Uh, Surprisingly, on this specific one, the KM 500 Pro, the mouse wheel hasn't gone bad yet, and it seems to be lasting pretty long. And I've actually been using this. It's not like I haven't been using it at all. I have been using this. So like I'm pleasantly surprised with how well this thing is holding up. So much so that I'm probably gonna order this again. The thing is, I feel like this is, I don't know if this is specifically an Indian brand because it seems to be available. So this one that we had got, it was from, because my mom was in India at the time. She was visiting in India at the time, so they had ordered it through Amazon India. And I tried looking on the other Amazon sites, and it doesn't seem to be available there. So that makes me think that this might be an Indian brand that's making this, and I might need to order it directly from Amazon India. So I don't know how the shipping is gonna go for that. I'm gonna have to see. But yeah, that's yeah. So, oh yeah, the mouse wheel. I was talking about the mouse wheel. So the thing with the mouse wheel is because because the wheels on each of these mice that I have, each of each of the mice that I have, they go bad pretty quickly. So I was thinking of making some sort of mouse wheel emulation and middle mouse button click emulation through a program. The thing is, the majority of the time I'd been aiming my development for this kind of an emulator towards Windows. So any sort of tech, any sort of research, any sort of OS specific thing that I was looking up, it was Windows related. And one major issue that I would run into was the fact that it would be a little bit complicated to read global events, or read just events in general, read like key presses in general. It would be a little bit complicated to do that, especially like if I was trying to, like, let's say app A was trying to read events, keyboard and mouse events, but app A needs to be able to read these events regardless if these events are being aimed at app B, app C, app D, app E, and so on. So basically, it's like a global event listener kind of thing. And I would have a few complications there. Also, at the time, I was trying to use the Windows API directly, the Win32 API directly, rather than using some higher level library. Anyways, I didn't really go too deep into that because I got busy with other projects. And then today I looked into it again. Only this time it was aimed at Linux, specifically Ubuntu Studio, with the i3 window manager running, and Ubuntu with the GNOME desktop environment running. Now, specifically for Ubuntu Studio with i3 Window Manager, there were a couple. I also mentioned. So I was having this conversation with Gemini about this thing, and Gemini gave a couple of suggestions. I did mention that I do Python and Rust coding if that can help at all. So there were three suggestions. One was using something called X input, through which we could emulate mouse input. But the catch there was that I would have to kind of reroute other mouse input, another type of mouse input to do this specific thing that I'm trying to do. So I wouldn't be able to route, let's say, a keyboard input. It would have to be a mouse input. Um, I don't remember if there was a way to do keyboard input emulation through that somehow. Though I wasn't trying to emulate keyboard input. I was trying to emulate mouse input through a keyboard shortcut. Either way, I decided not to go with that method. Another method was using something called the X dot tool or XDo tool, and then changing some of the configurations and setting up a key binding in the i3WM config. That's a thing that you can do. You can set up key bindings for doing various things. Then there was a Pythonic way, which used the Py input library. And then there was the Rust way, which used something called Amigo. And I like that idea. I like going with the Rust idea. So I started doing more research on that, and then that led me to asking more and more questions. Eventually, I was like, okay, what if I wanted to create something that listens for these keyboard and mouse events globally? That led me to another library called RDev that you can use to set up these listener events. Actually, give me a second. I need to step away for a couple of minutes. I will be back. Okay, I'm back. Sorry about that. I had to go take care of something, and that ended up taking me some time. Give me a second here. I also just came across this. There's apparently some kind of meme going. Oh, wait, let me switch back. Yeah, there's apparently some kind of meme amongst the younger generation, I guess. People who are in like high school and college, or high school and university, where they're being taught about three-dimensional frequency tables, and then they ask the question, can three-dimensional frequency tables be used to store complex data sets? I don't know what a three-dimensional frequency table is. I know what a frequency table, no, I know what a three-dimensional table is. I don't know what a three-dimensional frequency table is. So I know that a three-dimensional table can be used to store complex data sets, assuming the complex assuming the assuming the complexity in this case is uh, the higher dimensionality of the data or of the data set. Yes, it can. But I would like to test this out. I first need to read up on three-dimensional frequency tables. I need to first read up on frequency tables and understand what exactly they are. Because I'm wondering if it's just a sort of what was it called? There was a there was like a okay. So in pandas, when you have a data frame, you can use I believe it's the describe command to get a bunch of information about this data set, and it gives you a bunch of like statistics about the data set, stuff like min, max, um, average, and uh, I think counts of various things. I don't remember. Maybe it wasn't the describe method. Maybe it was something else. But there is some method that gives you a table that contains this kind of information. I don't know if this is referring to that specifically, but yeah, I'm gonna need to do some research because this seems like an interesting topic to do research on. I don't think I should be doing it on stream right now though, but maybe I could dedicate a stream to that only. Hold on. 3D frequency table. Uh, yeah, so this is something from stats. Somehow this became a meme. And again, I don't know what they mean by complex data sets. I don't know if the complexity of the data set is just the higher dimensionality of it, or if the complexity is, defined by something else. But I first need to find out what a three-dimensional frequency table is. So I'm gonna keep this one tab open. Okay, actually I could look up what is 3D frequency table, or I could have a conversation with Gemini about this. Okay, so this is leading to a Wikipedia page on frequency, which is relating to statistics. Okay, so in stats, the frequency or absolute frequency of an event, I, is the number of ni of times the observation has occurred slash been recorded in an experiment or study. This frequency, these frequencies are often depicted graphically or tabular form. Okay, the cumulative frequency, the relative frequency. Okay, a frequency distribution. Oh, okay, yeah, that's true. A histogram gives you it gives you the frequency distribution as well. Though with a histogram it's more like collective, right? Because the bins contain ranges of data, not necessarily always um, one specific value. Anyways, I shouldn't get too sucked into this. I'll keep this open and I can look into it later. For now, this is what we are looking into. Actually, this is what we are looking into, which reminds me, I was having that conversation with Gemini about splitting splitting the data, and there was a question that I had asked. Okay, to answer your specific question, the video part remains a video file. However, since you are removing the audio, it becomes a silent video file. Here's how the process works and the commands you'll need. Okay, cool. Extracting the audio. To get just the audio, you tell FFmpeg to disable the video recording using the VN flag. You can either copy the original audio, which is the fastest, or convert it to a new format like WAV. Okay. To WAV uncompressed and to MP3 is compressed. All right. Extracting the video, which is the silent file. To get the video without the audio, you tell FFmpeg to disable the audio recording. Disable the audio recording. Okay. All right. So they've given a couple of things here. Hold on. I need to. Okay, how demuxing works. In technical terms, what you are doing is called demuxing. An MP4 file is like a suitcase, a container that holds a video track and an audio track. You're simply taking them out of the suitcase and putting them in their own separate boxes. Okay, I have a question about okay, you mentioned video recording and audio recording. I'm very new to FFmpeg, so I'm not familiar with the workflow. If the video file, if let's say the MP4 file already exists, what recording is happening? Give me a second here. I'm just doing something. Need to put my phone on charge so I can keep. Oh, let's also reduce that volume. Right. Okay. So, what was I doing? Yeah. Okay, that's a great question. You are right to be confused. Since the file already exists, recording isn't happening, quote unquote recording, isn't happening in the sense of a camera or a screen capture. In the world of FFmpeg, the term recording is often used interchangeably with writing to a file. Oh, okay. When you run an FFmpeg command, you are essentially recording the data from your input file into a new output file. Give me a second. Let me hydrate and then I'll continue reading. Okay. All right. What is actually happening? Think of your MP4 file as a shipping container. Inside that container, there is a video reel and an audio tape. When you run the commands I gave you, FFmpeg does the following. It opens a container. It looks at the input file. It selects the tapes. If you use -vn, which is video none, it ignores the video reel and only grabs the audio. If you use AN, audio none, it ignores the audio tape and only grabs the video. Okay. Then the writing or recording process, transcoding. If you convert to a new format like WAV or MP3, FFmpeg reads the audio and re-records it into the new format. This takes a little time and CPU power. Stream copying. If you use -c copy, FFmpeg doesn't re-record anything. It just picks up the original digital data and places it into a new container. This is instant and doesn't lose any quality. Okay, that's interesting. So, okay, I have a question here. But wait, let me read the rest. Which should you use for a 2-hour VOD? Since your file is 2 hours long, you definitely want to avoid re-recording or transcoding if you don't have to, as it could take 20 to 30 minutes depending on your computer. For a video, always use CV copy. There's almost no reason to re-encode a silent version of a video you already have. For audio, use CA copy. If you just want the raw audio, usually AAC or M4A, only skip the copy part if you specifically need a WAV or MP3 file for a different program, like an old audio editor. You know what? I guess what I would be using here would depend on what the model accepts. Does the model only accept WAV, or does it also accept AAC and M4A? Because I don't remember seeing either of those being mentioned. So let me just look that up. Oh, actually, I think I have it open here. No, this was DistillBert, right? I was looking for DistillBert, Distill Small. I think it was Distill Small. Distill small.en. Oh yeah, it was Distill Small. Okay, so Distill small.en. Let's see what the input. Actually, you know what? No, hold up. If I can find something that can read AAC or M4A files and present them in a format that that this model expects, because I'm sure the model will be doing its own processing to pull the data that it needs, right? So what if I present the data in a way that the model needs? Okay, hold up. Usage, short form transcription. All right, okay. Auto model for speech sec to sec. D-type is torch D-type. What is torch D-type mentioned here? Float 16, else float 32. Okay. Where is the input? Dataset 0 audio. Where's dataset being? Dataset is being loaded here. Lib speech ASR. Oh, dude. Okay, I should keep this in mind. I should keep this in mind that this thing exists. Right. Anyways, so we get the audio from here. To transcribe a local audio file, simply pass the path to your so-and-so. Okay, but what are the supported audio formats? I need to understand that. I need to figure out what the supported audio formats are so I can decide whether to pass in the file directly, or if I should try and pull the data out first and then, because dude, I feel like if I did the transcoding thing, hold up. Oh God, this is loading up a whole bunch of things that I didn't mean to load. Okay, okay. All right. Um, okay, only skip the copy part if you specifically need a WAV file or so and so. Okay. The all-in-one workflow, if you want to do both at the same time without re-recording either one, use this. Okay. All right. Um, okay, explain the transcoding thing to me. Is it basically extracting the audio data and then applying a different encoding? Also, would not using copy somehow cause a desync? Okay, to understand transcoding, it helps to think of it as retranslating a book. What is transcoding? You are correct. Transcoding is a process where FFmpeg decodes the existing data back into its raw form and then re-encodes it into a new format. Extraction, it pulls the digital packets out. Decoding, it uncompresses them into raw frames or audio samples. Re-encoding, it compresses them again using a different math formula, the codec. Why do this? Usually because your target format uses a different language than the original source, likely AAC inside your Twitch MP4. If you don't use copy, FFmpeg assumes you want it to translate the file to the default format of the extension you provided. Does not using copy cause desync? Generally, no. In fact, transcoding is often the solution to desync, not the cause. Here's a breakdown of why sync issues happen. Why copy can sometimes cause desync. If your Twitch VOD has variable frame rate, common in streams where the PC lags occasionally, or corrupted timestamps, simply copying those broken timestamps into a new file can sometimes, or corrupted timestamps, then sometimes copying those broken timestamps into a new file can sometimes confuse media players, causing the audio to drift over time. Why transcoding is safer for the sync. When you transcode by not using copy, FFmpeg throws away the original timing metadata and creates a brand new timing grid based on the actual frames it sees. It forces the audio and video to line up. The downside, it takes much longer and causes generational loss, a tiny drop in quality. Okay. Summary. If your original VOD plays fine in VLC, using copy is safe and will keep it in sync. Only avoid copy if you find the resulting file if you find the resulting file is drifting. Okay, so here's my thing, right? I'm using I'm creating an auto clipper in Python that's gonna use HF transformers to load and run multiple models that are going to be doing things with this VOD files data. The thing is, the thing is, some models take audio data as input and some take video data. Very few of them actually require the full container. Now, the end result of all the processing through all the models is that I'm supposed to receive a set of start and end timestamps that will tell me where in the original VOD file should I slice to create multiple usable clips of interesting stuff. Actually, I think I should rephrase that. Tell me where in the original VOD file I can find useful information and based on those timestamps, I will then be slicing the original or slicing smaller clips out of the original VOD file. What I'm wondering is, since I'm doing this whole splitting thing and running inference using the separate video and separate audio files, is there a chance that the timestamps that get produced may not line up correctly with the original VOD? Okay. All right. This is a classic problem. This is a classic problem in automated media pipelines. The short answer is yes, there is a risk of timestamp drift, but it is manageable if you understand how FFmpeg and your Python models handle time. Since you are building an auto clipper, you are dealing with 3 different clocks: the container clock, which is MP4, the video stream, and the audio stream. The main risk, variable frame rate. Twitch VODs are notorious for having variable frame rate. If your streamer's PC lagged for a second, the MP4 might say 60 FPS, but for that 1 second, only 10 frames were actually recorded. The container knows exactly when each frame should appear. The model, most video transformers like Video May or Transformer assume a constant frame rate. Assume a constant frame rate. If the model thinks the video is exactly 30 FPS, but the VOD has missing frames, your model's inference will slowly drift away from the real world time. By the end of a 2 hour VOD, your timestamps could be off by several seconds. Okay, the start offset trap. Many VODs don't actually start at 000. The audio stream might start 200 milliseconds before the video stream. Sorry, zoned out. What was I? Where was I? The audio stream might start 200 milliseconds before the video stream. When you split them into separate files, some ML libraries ignore the start time, metadata, and assume the first byte is time 0. If your audio model finds an event at 10 minutes and your video model finds it at 10 minutes, they might actually be referring to different moments in if one stream started later than the other in the original file. How to prevent desync in your autoclipper. To ensure your Python generated timestamps line up with the final ffmpeg slice command, follow these 3 rules. Force constant frame rate during extraction. When you extract the video for your model, force it to a standard frame rate. This ensures that frame number 1800 always equals exactly 30 seconds in both your model and your math. Okay, where exactly is this being forced? I think it's where it's mentioning libx264. Okay, rule B, use copy TS and start at 0. When splitting files, tell ffmpeg to preserve the original timestamps so the internal time of the audio file matches the internal time of the video file. All right, slice using the input seeking method. When you finally use your Python timestamps to cut the clips, put SS before the I flag. This tells ffmpeg to use the container's global time to find the spot, which is much more accurate. Correct Python subprocess command. Split the inference, extract the audio as wave and video as as a fixed FPS MP4 inference, run your model, so and so. Okay. Right. So I have a bit of research to do here. Is there any way to find out if the video is variable frame rate? Also, I'm assuming also if I go with the transcoding option, is desync a risk or are we fine? Also, Sorry, zoned out. Um, yeah, okay. Um, Also, I forgot if there's an also. So I was asking about how I should find out the variable frame rate thing. Um, also, I think I need to reread this answer. But yeah, also if I go with the transcoding option, yeah, okay. I don't remember. Okay, let's just get this answer. Finding out if a video is variable frame rate is the first thing you should do when building an automated pipeline. As Twitch VODs are almost always VFR, variable frame rate, due to how encoders like OBS handle performance dips. How to check how to check for VFR, the VFR det method. You can use the VFR det filter in FFmpeg. This command won't create a new file. It's just analyzing the stream and outputs the result to your terminal. How to read the results. Look for a line in the output that looks like this. Parsed so and so so and so. Um, okay. All right. Let's try this. Let's try this. So we what is this for? Oh, this is my let's say, does this count as bionics? I don't know. But yeah, my plants with electronics thing that I was setting up. This is being a little slow right now, so I think I'll go to the next tab. I can close this. I can do it in this thing alone. So we'll do what is the command? ffmpeg I input dot okay. ffmpeg I data. Actually, let's cd into data. Then ffmpeg I okay, vfr det an, and then f null. Okay, I'm gonna need to read what each of these does. Null and this. No such filter, vfr det. I made a mistake here. This. All right, let's store it into analysis underscore data dot txt. Okay, that's interesting. It's still, oh, wait. That's interesting. Hold on, that's crazy. Okay, this is interesting. So this wasn't happening before. I asked it to write to a file, but now it's happening. Okay, parsed. Wait, I'm hearing my fans going off. Is what's hold on. Give me a second. Oh damn. Okay. FFmpeg is busy. It is busy. Okay. Right. Uh I'm wondering if I should have only done a couple of seconds of this. But okay, while this is happening, we'll continue with this. How to read the results. Look for a line in the output that looks like this. Oh, damn. Okay, that's getting louder. Oh, it's getting louder because of the temperature. How much longer is this going to be? I don't know if I should let this just... Wait, I'm curious about whether I entered the correct thing. Oh God, it's getting louder. Uh, Hold on. Did it mention how many frames there were? Duration 2.5 hours. Oh, wait, are we done? Okay, I think we're done. Okay, all right. Let's open up analysis data.txt. It didn't write shit. Okay, great. Let's just copy this entire thing and I'll drop it into Gemini. Actually, I don't know if it's gonna copy properly. Uh, okay, so I'm gonna copy it and drop it in here. Okay, that log is definitive proof that your video is variable frame rate, decoding your VFR det results. Here's exactly what the last line means. VFR 0.8. Okay, let me come back here. Where is it? Where does it say VFR? Oh, there. Okay. VFR 0.8 so and so. This is a VFR score. Since it's not zero, the video is objectively VFR. a score of 0.8 is actually quite high, meaning a huge portion of your frames do not follow a standard rhythm. I think that might be because of the dropped frames that I often have. Okay, the number of frames that have a non-standard duration is 218,000. What? 218,000. Okay, the number of frames that match the expected duration is 54,000. Okay, where are those numbers here? Okay. Conclusion, only about 20% of your video frames are normal. The rest are slightly longer or slightly shorter than they should be. Minimum 2,880, maximum 3,060. These are time base units per frame. It shows the jitter. Some frames are shorter and some are longer. Is desync a risk with transcoding? To answer your second question, no, transcoding is actually your safety net here. If you were to simply copy the streams, you would be passing that jitter, the 218,883 weird frames, directly to your AI models. Most AI models, like those in the Hugging Face Transformers, assume a perfectly steady clock. If the model processes 30 frames and assumes 1 second has passed, but those 30 frames actually took 1.2 seconds in real life, your timestamps will drift. By transcoding to CFR, constant frame rate, you fix this. When you force the output to 30 frames per second, FFmpeg looks at those min-max durations and essentially realigns them to a grid. If a frame was too long, FFmpeg might duplicate a frame to fill the gap. Okay, something that I'm concerned about here is that am I going to need to transcode the entire video first to CFR and then do whatever I need to do? And if I do actually do that, um, what was I saying? Yeah, if I do actually do that, could that affect the quality of the video or the audio at all? Okay, I have one thing that I could do here, and that is, okay, so this is all affecting video, right? I think so. This is all affecting video. Yes, this is all affecting video. So for the time being, we are mainly working with audio, right? We are not getting into the video side of things yet. However, yeah, no, I need to figure out, because I don't want to transcode the entire video and then end up with, like, jittery portions here and there in the video just because I tried to give it a constant frame rate, or maybe there's like weird artifacting happening in the video just because I tried to give it a constant frame rate. Um, okay, hold up. If I convert, wait, no, wait, so the solution here is to first convert the VOD from VFR to CFR and then perform the split. Actually, you can do both at the same time. You don't need to create a massive intermediate CFR file. You can tell FFmpeg to translate the VOD to CFR as it is splitting it into separate audio and video files for your models. This saves you disk space and a lot of processing time. The all-in-one pre-processing command. Since your Twitch VOD is 2.5 hours long, sorry, zoned out. Okay. Since your Twitch VOD is 2.5 hours long, you want to avoid writing to the disk more than necessary. Use this command to generate your model ready files. Alignment. By using one command, FFmpeg uses the same internal clock for both outputs. Okay, but is this going to ensure that the final timestamps that I get align perfectly with the original VOD with VFR? This is the million-dollar question for AutoClipper developers. The short answer is yes, but only if you use global time as your source of truth. If you rely on frame counts, example, the event happened at frame 10,000, you will almost certainly experience drift. If you rely on timestamps, the event happened at so-and-so time, you will be perfectly fine. Here's the technical reason why and the safety checklist to ensure your clips are perfect. Okay, the source of truth, global PTS, presentation timestamp. Every frame in your original VOD has a PTS. In a VFR video, these timestamps are irregular. Example, frame 1 is at 0 milliseconds, frame 2 is at 33 milliseconds, frame 3 is at 70 milliseconds. When you transcode to CFR for your models, FFmpeg uses a process called vsync to align these irregular timestamps to a rigid 30 FPS grid. Because FFmpeg snaps the frames to the nearest available timestamp in the new grid, the clock at the end of the 2-hour video remains the same. Okay, 2 hours in your pre-processed file will refer to the exact same wall clock moment at 2 hours in the original VOD. The drift trap, frames versus seconds. This is where most people fail. Bad logic. My model found an event at frame 1800. Since I converted to 30 FPS, that's exactly 60 seconds. I'll cut 60 seconds into the original VOD. Why it fails? In the original VFR VOD, frame 1800 might have actually occurred at 58 seconds or 62 seconds. Because the frame rate was fluctuating. Okay, your perfect alignment checklist. No, hold on. So trying to get this timing right, it's going to be a little bit complicated. Okay, now hear me out. What if after getting, no, what if, no, wait, let's say I don't convert from VFR to CFR and just split the audio and video. We now have the, the possibility of desync or drift. Okay, cool. What if after getting the final timestamps, I add a bit of padding before the start timestamp and after the end timestamp. Let's say 10 to 15 seconds. So that way, I can later view the entire clip and trim out what I don't need. Do you think this would work? See, okay, one issue here is like we're trying to ask an LLM if, hey, do you think this is a good idea? Do you think this is going to work? One issue that I've noticed is that sometimes they'll be like, yeah, this will definitely work. Oh, yeah, this will definitely, unless there's something that could immediately break the entire logic, or make things incredibly slow. Like unless there's like a highly negative outcome of it, they're going to say, yeah, this can definitely work. You can definitely do this. So I need to be careful of that as well. Okay, anyways, the answer here is this is a very practical safety net approach, and honestly, many professional workflows use padding exactly for this reason. However, since you're dealing with a 2-hour VFR file, there's one specific technical trap you need to be aware of. Does padding fix the desync? Mostly yes. If the drift was caused by VFR, the audio and video might slow down, might slowly move apart. In a 2-hour Twitch VOD, it's common to see a drift of 1 to 5 seconds by the end. If your drift is 3 seconds and you add 15 seconds of padding, your quote unquote action will still be inside that 30-second window. You won't miss the highlight, but it might not be centered where you expect it. The danger, keyframe snap. The bigger issue you'll face isn't just drift, it's keyframe alignment. Hold on. Yeah, keyframe alignment. When you use C copy, which is instant and lossless, FFmpeg can only cut the video at a keyframe. If you ask it to cut at 1 hour, 10 minutes, and 5 seconds, but the nearest keyframe is at 1 hour, 10 minutes, and 0 seconds, then FFmpeg will only start the video at 1 hour, 10 seconds, and 0, 1 hour, 10 minutes, and 0 seconds, but start the audio at 1 hour, 10 minutes, and 5 seconds. Okay. The result, your clip starts with 5 seconds of Oh, that's interesting. I didn't realize that that could be a reason why this happens. I've actually noticed that in certain videos where it's like the audio starts, but then the frame is kind of frozen. And then after a couple of seconds, it continues playing or actually starts playing. Anyways, this is a very common desync that happens even on perfectly healthy files. My recommendation is the hybrid strategy. If you want to stick with your padding idea, which is smart, you should use this specific logic in your Python scripts. Extract for the models. Keep using the CFR split I mentioned before. This ensures the timestamps your AI gives. This ensures the timestamps your AI gives you are mathematically accurate to the real world clock. Add padding. Take your AI's timestamp, and expand it, okay? And then the accurate cut, when you perform the final cut from the original VOD, use SS before and, okay, all right. This forces FFmpeg to find the closest keyframe before your timestamp, which helps keep the audio and video in sync. Wait, how does that help keep it in sync? Okay, when you perform the final cut from the original VFR VOD, use the SS before the I flag. This forces FFmpeg to find the closest keyframe before your timestamp, which helps keep the audio and video in sync. Okay. Summary: is 15 seconds enough? For a 2-hour VOD, 15 seconds is plenty. Drift rarely exceeds 5 seconds unless the stream was extremely laggy. The padding will comfortably cover both the VFR drift and the keyframe snap issue. Okay, hold on. The whole converting CFR to VFR thing seems a bit tedious right now. What if I just didn't do that? How bad would it be? Also, the CFR slash VFR thing mainly applies to audio, right? No, to video, right? If the majority of my inference is being done on audio, then do I still need to worry about drift issues even if I use padding? Hello, Sionix. Hello, hello. How's it going? Welcome to the stream. We are currently doing some research on what are we doing research on? We're doing research on how videos tend to have, or more specifically Twitch VODs tend to have a bit of like a desync between the audio and video. And this is caused because of the video having variable frame rate, apparently. And so because I'm building an auto clipper kind of application that's going to pass both the audio track and the video track into various types of models to then determine if there are specific interesting portions in that audio track or video track, and then it's going to tell me, hey, okay, this can be clipped, that can be clipped, this is interesting, that is interesting, stuff like that. Yeah, we're just doing a bit of research on that. Okay, I totally hear you. When you're in the middle of building a Python app, the last thing you want is an extra heavy processing step that feels like busy work. The good news is, if your models are mostly using audio, you are much safer. Here's a breakdown of why you can probably skip the CFR conversion and how to do it safely with your padding idea. Is the drift mainly a video thing? Yes. VFR, variable frame rate, is a video-specific property. Audio is almost always constant sample rate, which is 48,000 samples per second. Yeah, ours could be 48K or 44.1K. The audio stream likely a steady heartbeat. It doesn't care, like a steady heartbeat. It doesn't care if the video lags, it just keeps playing at its fixed rate. The problem, when you ask a model to look at minute 10 of the audio and minute 10 of the video, they might see different things because the video frames bunched up or spread out while the audio stayed steady. Okay. Can you skip CFR conversion? Yes, you can if your inference is primarily audio driven. If your inference is primarily audio driven, the timestamps you get from the audio model, like Whisper or Wave to Vec2, will be wall clock accurate. If you use those timestamps to cut the original VOD and you add 10 to 15 seconds of padding, you are effectively catching any small video drift that occurred. The low effort workflow. Since you want to avoid the tedious conversion, use this command to split your files. It uses stream copy for everything, so it will take seconds instead of minutes. Why padding is your best friend here? By adding padding, yeah, okay, I get that. So we'll catch the drift, we'll catch the keyframe gap. Great. Final lazy but safe strategy. I like that. Okay, all right. One final warning. If you use a video only model like a gesture recognizer on a VFR file without converting to CFR, the model might get confused because it expects frames to happen at a steady rhythm. If that happens, the model's internal sense of time will be wrong, but if you're doing mostly audio, you're golden. Okay. All right. So here's what I'm gonna do. Okay. I am going to end the stream here. Okay. I really should have started a little bit earlier, but honestly, it was my fault. I started later than I planned to. That's on me. But I mean, we got a good 1.5 hour stream in, so that's great. But yeah. That being said, let's see if anyone else. I mean, yeah, definitely people are live. Let's go look for somebody to raid. Just a second, just a second. Okay, somebody is doing some reading. Not sure what they're reading. Uh, let's read Howl's Moving Castle. So they're reading something called Howl's Moving Castle. We are gonna go to this person's stream. I hope they don't have any settings that prevent a raid in general, or a raid from smaller channels, or yeah, we're good. Okay, awesome. I still have to continue this conversation with Gemini because there's a couple of questions that I have to ask, a couple of doubts that I have to clear, and then I can get started with this. Yeah, because a lot of what I'm going to be doing is audio based. It's not video based, but like video will come in later on. So that could be an issue, right? So I need to account for that as well. So I need to take some time and learn about all of the VFR, CFR stuff through FFmpeg. I just remembered that yeah, I have this RAID timer thing going. So yeah, I'm gonna end the stream now, and hopefully I'll be streaming again tomorrow. We have a pretty decent streak going now, and hopefully the streak is gonna continue. There's no reason to, not stream on any given day so far. So far things seem to be going well, and hopefully they remain that way. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day. CEO Nix or Sionix, thanks for stopping by. Anyone else who might have been lurking in the stream, thanks for hanging out. I'll see you guys next time.